Hi guys, welcome back. This video would be the last video for this course. In this video I will talk about assignment 1, exam 1 and practice exam for exam 2. So first is the assignment 1, homework 1, and I will go through questions one by one. So the first question from assignment 1 asks us to identify the following terms on this graph. So as we can see on this graph, the downward sloping curve is the demand curve and the upward sloping curve is the supply curve. Their intersection point is the market equilibrium, and the corresponding quantity is the equilibrium quantity. The corresponding price is equilibrium price. So when we talk about the price and the quantity, we need to find the exact value of that. Suppose the equilibrium point is here, then the corresponding price should be 5. So this intersection point is not the equilibrium quantity or price. It is just the equilibrium point and represents the price and the quantity at the same time. And consumer surplus and producer surplus. Consumer surplus is the area under the demand curve but above the market price curve. So from this graph, the market price is 4 and the demand curve is this line. So the area between demand curve and the market price should be this purple area, and the producer surplus is the area above the supply curve but below the market price. So it should be this orange area. So here is the answer for question 1. For question 2, first, this question is about the negative externality. So when we think about the marginal costs, we need to take the pollution damage into consideration. So if the market equilibrium does not think about the pollution damages, does not take the marginal damage cost into consideration, then the market equilibrium is not efficient. Because the market equilibrium is not equal to the social equilibrium, the price to pollute is so cheap and there would be overproduction. So question A on the graph, mark the point representing the market equilibrium and label it E, and label the equilibrium quantity QM and the equilibrium price PM. So question A, we need to first find the market equilibrium. So the market equilibrium is the intersection of marginal private cost curve and the marginal benefits curve. So for marginal private cost curve, we don't need to think the pollution damages into consideration. So it is given by MPC equal to 2 plus 2Q. And the marginal benefits curve is 20 minus 4Q. So from this graph, I already plot those two curves. Then the intersection should be market equilibrium, and the market equilibrium quantity should be exactly 3. The market equilibrium price should be 8. So that's for question A. And for question B, plot the marginal social cost function on the same graph and mark the point representing the social equilibrium and label the social optimal equilibrium quantity QO and the equilibrium price PO. So we already know the marginal private cost, the marginal benefits, and we also know the pollution damages are equal to MD equal to 6. And then the marginal social cost curve would be a sum of marginal private cost and marginal damage, which should be 8 plus 2Q. So when we plot 8 plus 2Q on the graph, we get the marginal social cost curve. Here it is. And then the social equilibrium would be the intersection of marginal social cost and the marginal private cost. So remember, in this case, marginal private cost is equalized to marginal social, marginal private benefit is equalized to marginal social benefit because there is no positive externality. So those two curves are just exactly the same. So as we can see on this graph, the intersection of marginal social costs and marginal private costs is here is O, and then the corresponding price and quantity should be social equilibrium price and quantity. Social equilibrium price is 12 and the social equilibrium quantity is 2, comparing to the market equilibrium quantity. So at the social optimal level, we should produce less and the price would be higher. And for question C, shade the area representing producers surplus and consumer surplus at the socially optimal allocation. Again, the consumer surplus would be the area under the demand curve, and the producer surplus would be the area above the supply curve. And in this example, in this case, the demand curve, we also call it the marginal private cost curve, and the supply curve, we call it the marginal social cost curve. So at the socially optimal level, the area below the marginal private curve but above the market price should be this green area, and the area above the marginal social cost curve but below the market price should be this green area. So that is for question C. And for E, shade the area that represents the deadweight loss to society when production is at the market equilibrium. So for this one, there is a very simple way to find the deadweight loss due to the market equilibrium. First, we find the market equilibrium point. It is the intersection of marginal private cost and the marginal private benefits curve should be E. And then O is the social optimal level. Then we find the market equilibrium quantity QM. We connect E and QM, extend this line to the marginal social cost curve. We find A, and then the triangle enclosed by AEO is the deadweight loss. So this way is very simple to find the deadweight loss anywhere for this kind of questions. And there is also another method. We need to calculate the total, the net benefit under each equilibrium. First, under the market equilibrium, we need to calculate the social net benefit, and then under social equilibrium, we need to find the net benefit, and then the difference between those two net benefits should be our deadweight loss. So for that one, I talked a lot in the lecture notes. If you are interested in it, you can go back to the lecture to see how I calculate the net benefit under each equilibrium. Under what for question 3, under what conditions does cost theorem bargaining work, and give one example of an externality where the cost theorem does not work. So there are so many conditions to make cost theorem works. First, property rights, they have to be well defined, and property rights are tradable. We can ignore the transaction costs. That means there would be free negotiation between each parties, and there are small number of parties, and those parties can be easily identified. So those are the conditions for cost theorem to work. And in some conditions, it does not work. For example, if the property rights are ill-defined, then it does not work. If the property rights are not tradable, it does not work. Question 4 is about the public good, and we need to calculate the aggregate demand curve for a public good and plot the aggregate demand curve. So there are 3 people, John, Dave, and Becky, and here are their individual demand curves, and given the price is our supply curve, also our marginal cost curve, and which is constant. So we need to plot, for question A, we need to plot the supply curve and everyone's independent demand curve. Here it is. The dashed line is the supply curve, and the blue lines are everyone's independent demand curve. And for question B, we need to plot the aggregate demand curve for the candles and the supply curve for the candles. So the supply curve would still be this one, this horizontal line, which should be equal to the price 6, and this dashed line is our supply curve, still is our supply curve, and the aggregate demand curve would be the vertical sum of everyone's independent demand curve. So here, when we say when the quantity of the mosquito control is equal to 0, then John's demand and Becky's demand would be 5, right? And Dave's demand is 10. Then the aggregate demand should be 20, because the aggregate demand for a public good should be a sum of everyone's willingness to pay. But keep in mind there is a kink, which is here, because when the quantity of the mosquito control is greater than 5 but less than 10, only Becky is willing to pay for the candle. So which means when the quantity is greater than 5, we only need to think about Becky's demand curve. So that is where the kink comes from. And for question 5, list any 3 reviewed preference methods for valuing environmental risks and provide examples of situations in which each method is proper. So the reviewed preference methods are listed here. First, the travel cost method, and then hedonic property pricing method, hedonic wage method. So the last one would be averting expenditure method, and the examples of each method are also listed here. So I would post this file under week 8, and then you can check one by one by yourself. And question 6 is about the pollution permits. And first, we need to calculate the total abatement costs for each firm and fill out this table. And there are 2 firms, the pollution units and the marginal abatement costs for each unit are given under each firm. So let's start the IM clean firm first. And when there is 1 unit of pollution, the marginal abatement cost is 1, and that means the abatement cost for this 1 unit pollution is equal to 1. Then our total abatement cost for 1 unit of pollution would also be 1. And suppose we want to pollute extra unit of the pollution, then the total amount of the pollution would be 2, and the marginal abatement cost for this extra unit of the pollution is 2, and we already know the total abatement cost for 1 unit of the pollution is 1. Then the total abatement costs for 2 units of the pollution should be 1 plus 2, should be 3. And suppose we are going to pollute one more pollution, the third one, and the marginal abatement cost for this third unit of pollution is 3, and we already know the total abatement cost for 2 units of pollution is 3, and then the total abatement cost for 3 units of pollution should be 3 plus 3, should be 6. And when we go through this box one by one, we can finish this table for each firm, and this table is the final one what we need for question A. And for question B, the government wants to reduce the environmental impact by a total of 8 units. And to achieve this target, the government imposes a standard that each firm must reduce its emission by 4 units. Then, what is the total abatement cost incurred to achieve this target? So for question B, we are not talking about the tradable units. We are not talking about the tradable permits. We are only talking about the total abatement cost for 4 units of the pollution. And for clean firm, the total abatement costs for 4 units of pollution is 10. And for the dirty firm, the total abatement costs for 4 units of pollution is 30. Then the total abatement costs from those 2 firms should be 10 plus 30, which should be 40. And that is the total abatement cost incurred to achieve this target. And that's all for assignment 1. Then I will go to the exam 1. And I will go through all questions in exam 1. And the first question, according to the formula to get the present value of any future payment, that is talking about this formula, and R is the discount rate, N is the number of periods in the future, and the present value would decrease or increase if the discount rate is increased. So if the discount is increased, then this term would be increased, and the total term would be decreased. So that also means the present value would decrease, and the present value would, if the amount of the payment is increased. So this one is quite clear. If the FV is increased, and then the present value should also increase. So the correct answer is decrease and increase. In the graph below, MAC1 and MAC2 are marginal abatement cost curves for firm 1 and firm 2 respectively. So what does triangle ADC represent? So the triangle ADC represents firm 1's earning from the trade with firm 2, and the DHG represents firm 2's earning or firm 2's saving from the trade gain with firm 1. So the sum of ADC and DHG is the total saving from the trade gain. And for question 2, the correct answer is firm 1's saving from permit trade. And question 3, which of the following is not a conclusion about market allocations of commodities causing pollution externalities? So there are so many reasons cause the pollution externality. For example, the price of the product is too low, and the output, the production of the product is too high, and the recycling and the reuse of the pollution are discouraged because pollution is so cheap. So B, C, D are all correct except A. The price of the products are too high. If the price of the products are too high, then there would be low production, and from that perspective, the pollution externality would be decreased. And question 4, marginal abatement cost function represents what? The correct answer is A, the additional cost of reducing pollution by another unit. So when we are talking about marginal, like the marginal cost, marginal benefit, we are always talking about the value by another unit. For example, when we are talking about the assignment 1, the marginal abatement cost, that represents the extra cost for 1 more unit of pollution. So here the correct answer is A. 5. Social efficient allocation of a good with costs that are external to the production process occurs at. So for this one, we need to find the conditions of the social efficient allocation. The social allocation is efficient or is optimal when we have marginal social cost curve is equal to marginal private benefits curve. So the condition should be C. And 6, the costs in cost and benefit analysis are derived from the cost. And when we talk about the cost, we are talking about the producer's side. So from the producer's side, everything related to cost would be related to this term, the cost in cost and benefit analysis. So the supply curve definitely the producer's curve, and the total willingness to accept is the producer's total willingness to accept the price that the producer is willing to accept, and the marginal cost exactly is highly related to the cost. So the correct answer is D, all of the above. For question 7, using the graph below, find the total willingness to pay or the benefits for a good with a market price of 7. So keep in mind here, we need to find the total benefits rather than the net benefits, rather than producer surplus or consumer surplus. So the total benefits would be the area under the demand curve, and this downward sloping line is our demand curve. The market price is 7, and the market quantity corresponding to this market price would be 1. So the area under the demand curve would be A, B, C. So the correct answer is C. And 7, which of the following is an example of market failure? First one, externality is an example of market failure. Low price or high price is determined by the market equilibrium. The supply and demand are also determined by market. Excludable and rival goods, they are referring to the private goods, and when there is a market for private goods, then it is not a market failure. So only A, externality, is one example of market failure. And 9, an uncrowded toll road is a public good or not, because it is. So an uncrowded toll road is not a pure public good because it is non-rival but excludable. So we cannot drive on the toll road if we didn't pay for that, right? So it is excludable. However, it is uncrowded, means my consumption of this road will not decrease the amount available for you to consume because it is uncrowded. If it is a crowded toll road, then it is rival. So the correct answer for 9 is A. And question 10, which of the following statements is not true about dynamic efficiency? Only C is incorrect because it states the total benefits are equally distributed across all time periods. But when we talk about the dynamic efficiency, we want to equalize the present value of net benefits across all time periods, not the total benefits. So C is not correct. And then we move to the short answers. First, we need to list the conditions for cost theorem, which is exactly the same as we did in assignment 1. And question B, a firm would produce some pollution to the water and it would affect the well-being of the residents who live downstream. So use this example as answer the following questions: the concept of willingness to pay and willingness to accept, and how these two concepts apply to this example. The definitions are available from our lecture notes. The willingness to pay measures how much the firm is willing to pay to produce the pollution, and the willingness to accept measures how much the residents downstream who live downstream are willing to accept to tolerate the pollution. So in our case, when there is a payment to impact the residents, it represents the willingness to pay because they need to tolerate the pollution from the polluting firm. And question 2, we need to define, first we need to define the non-rival and the non-excludable. Non-excludable means we cannot exclude those who fail to pay from using the good. And remember this question, a toll road is an excludable good, because if you fail to pay for the toll road, you cannot use it. And the non-rival means the consumption of one individual does not reduce the amount of the good available to others. And go back to our question 9, the example of uncrowded toll road, because the toll road is uncrowded, so my consumption of the toll road would not reduce the amount available for you to consume. So that is the meaning of non-rival. And when we check the question B, again, it is an aggregate demand curve question, and for each level of quantity, we need to find everyone's willingness to pay, and the aggregate demand for this public good would be the sum of those for everyone's willingness to pay. And first, when the quantity is 0, the willingness to pay for everyone would be 2, 3, and 4 respectively. Then the aggregate demand would be 9, and we do this one by one. Then we get the aggregate demand corresponding to the quantity. The third question would be about the graph. We need to plot first individual demand, 3 individual demand curve, and the aggregate demand curve, and the supply curve. Given the price is equal to 1, it is constant, so the price would be this line, would be this horizontal line, and the blue, orange, gray line just represents everyone's independent demand curve, and the aggregate demand for this public good would be this yellow line. But keep in mind there are 2 kinks, and remember when we talk about assignment 1, there is just 1 kink. So the difference is that when the quantity of this public good is greater than 2, only Bob and Anna are willing to pay for this public good, and when the quantity is greater than 3, only Anna is willing to pay for this public good. So there would be 2 kinks, and it is very important for you to point out where the kink is. And the last question, how many units of this public good would they buy at the social equilibrium? So at the social equilibrium, we need to think about the aggregate demand curve. So this yellow line is the aggregate demand curve, and the supply is this dark blue line. So the intersection of the yellow line and the dark line would be here. The corresponding quantity should be 3, and that means the total units they would buy would be equal to 3. And question 3, it is about the marginal abatement cost. And suppose there are two firms, one with higher marginal abatement cost and one with lower marginal abatement cost. And I already plot the marginal abatement cost curves for those two firms. Blue one represents firm 1 and the orange one represents firm 2. And question A, which firm has higher abatement costs? Which is quite simple. The orange one, the firm 2, has higher abatement costs. And if government imposed a tax of $4 per unit of emission and draw a line that represents this tax and show the optimal level of pollution abated for each firm, the tax would be this dark line, this black line, and which is a horizontal line and exactly equal to $4 per unit. And the intersection of this black line and those two marginal abatement cost is each firm's optimal level to abate. For firm 2, the optimal level to abate is around 3 units, and for firm 1, the optimal level to abate is around 5 units. And shade the area that represents the total abatement costs for firm 1 at its optimal level of abatement. So we are talking about the firm 1, so we need to focus on the blue line. The intersection of this blue line and the dark line is A, means A is the optimal level decided by those two lines. The corresponding quantity is the pollution abatement for firm 1, which is exactly 5. And that means the area under the marginal abatement cost curve, but below the x-axis is the total abatement cost, and the area below the tax but above the x-axis is the total tax that firm 1 has to pay. So we already know the total emissions for each firm is 10 units, and they need to, for firm 1, it has to abate 5 units. So that means there are 5 units left, and for those 5 units, it has to pay the tax for it. So ABC represents the total abatement cost, and ACDE represents the total tax that firm 1 has to pay. The last question, what would be the optimal level of emissions for firm 1? And as we already know, the total abatement for firm 1 should be equal to 5, and the unregulated emissions for firm 1 are equal to 10 units. Then the optimal emission is equal to the difference between unregulated emissions and optimal abatement, which should also be equal to 5. Question 4 is a dynamic question. There are 2 periods in total, and the total quantity of mine available to extract is 24 tons, and the marginal cost of extraction is equal to 2. The demand function is given, and that means the marginal net benefit should be the difference between demand function and the marginal cost of extraction, should be equal to 8 minus 0.5 times Q. So the discount rate for this question is equal to 10%. And given all those informations, we need to calculate the present value of marginal net benefits in each period. For period 1, we don't need to think about the the discount rate because we just regard the period 1 as the current period. So the present value of marginal net benefit in period 1 should be exactly equal to 8 minus 0.5 times Q1. And for period 2, we need to think about the discount rate, and here is the final present value of marginal net benefit in period 2. And for question B, we need to plot those two functions on the graph. The left y-axis represents the marginal net benefit in period 1, and the right y-axis represents the present value of marginal net benefit in period 2. For x-axis, from left to right end, it represents the amount of resource to extract in period 1, and from the right to the left end, it represents the amount for period 2 to extract. So when we plot those two functions on the graph, we should get the black line and the red line. And the black line represents the present value of marginal net benefit in period 1, and the red line represents that for the period 2. And the optimal allocation should be determined by the intersection of those two lines, should be exactly E, because when we extract more in period 1 or extract less in period 1, the total net benefit would not be maximized. Only at this point, the total net benefit would be maximized. And last question, what is the efficiency loss? What is the deadweight loss if 14 units of the resource is extracted in period 1 and the remaining 10 units in period 2, and label it on the same graph? So if we consume 14 units in period 1, then the total net benefits would be enclosed by those yellow lines, and this small triangle would be the deadweight loss. And that's all for exam 1. Then I would move to the practice exam for exam 2. Then we are going to talk about the practice exam of exam 2. For question 1, A, B, C are all renewable resources. And for question 2, the following graph represents total benefits and total costs of fishing effort. And on the graph, which point represents the expected level of effort under open access? So E3 would represent this effort, because under open access, each individual would have incentive to exploit this resource until there is nothing left. So at that point, the total benefits would be equal to the total costs, and the profit would be 0 for everyone. So E1 is the point we can get the efficient allocation, because at this point, the marginal net benefit, the tangent line of this point, is equal to the slope of total costs curve. So E1 is the efficient level of allocation, and E2 is maximized mean yield. And it is the optimal level from biological management's perspective, but not from our economics perspective. And for question 3, what does K represent, and is it stable? So K represents the carrying capacity, and it is stable because when there is a shock to reduce the fish stock, for example at this amount, however the growth rate is still positive, that means the fish stock would still increase until it achieves this point again. So K is stable. For S, it is the minimal viable population. It is unstable because when there is a shock to increase the fish stock, for example to this point, the growth rate would be positive, right? And then the fish stock would continue to increase, to deviate from this point. And suppose the shock is negative, and it would decrease the fish stock to this level, and at this level the corresponding growth rate would be negative. So that means the fish stock would decrease until it achieves 0, and it would still also like deviate from this point. So S is not stable, but K is stable. And for the economic optimal harvest age of a standing forest is determined by the marginal cost of waiting another year and the marginal benefits of waiting one more year. When the marginal cost is equal to the marginal benefits, then that is the optimal harvest age. And if the discount rate decreases, the optimal forest age would increase. And on the other hand, if the discount rate increases, then the optimal forest harvest age would decrease, because the cost to wait one more year would be increased. And the figure below represents the land use pattern in a polocentric city, because there are so many CBDs and one declining inner city. So that is the polocentric city. For question 7, which of the following is a climate adaptation policy? Only C is a climate adaptation policy. And for question 8, which one places highest value on the very distant future? The green-golden rule places the highest value on the future, and the first one places the value on the present. And B, Rosen intergenerational equity, we need to balance the equity, equalize the equity for each generations. And for question 9, how much water would user B receive if we efficiently allocate water under the S1 supply condition? So under the S1 water condition, A's willingness to pay, or we can say A's price for water would be M and B1. And at this level, B was willing to pay nothing at this level. So when the water supply is equal to S1, only A would get all of the water and B would get nothing. So the correct answer is 0. However, at this level, if the water supply is equal to S0, and then we find the social optimal level, which is the intersection of aggregate marginal net benefit and S1, should be here. And then we drop this line to we can find everyone's willingness to pay, and A's and B's willingness to pay are equalized, and then we can find everyone's quantity for the water. So for B, the quantity should be equal to QB0. For A, when the willingness to pay is equal to M and B0, the quantity should be equal to QA0. So that is the condition under the water supply S0. For S1, A would get everything. A would get all of the water, and B would get nothing. And for question 10, the correct answer is A, and it is just the definition of Hartwig rule. Then we move to the short answers. First, we need to list 3 externalities related to the harvesting timber, and discuss any one government policy to manage forests. And here are externalities related to harvesting timber. For example, the climate change, human health, and loss of biodiversity, ecosystem, harmful to ecosystem. All of those are externalities. And the policies we talk about, we listed so many policies, and either one is fine to be listed here. And question B, how is biological management different from the economic management of forest? And use the concept of mean annual increment and present value net benefit. So first we need to understand the concept of mean annual increment. Here is the concept, the definition. Mean annual increment is the volume of trees at age t divided by the age of the stand. And the mean annual increment is maximized when the marginal growth at time t is equal to the average annual growth, and it is a biological concept because it only cares about the volume of the tree. It does not think about the costs and the benefits corresponding to the human activity. However, from the economic management's perspective, we need to think about the discount rate, the costs of our activity, the benefits from our activity, and we need to think about the present value of the net benefits, or the present value of difference between total benefits and total costs. So that is economic management. And the second question, why is climate change a global public goods problem? What is fundamentally different about climate change compared to other environmental issues? So I would like to explain the second question, the fundamental difference between the climate problem and other environmental issues. So remember, when we talk about the pollution control, there are two different types of costs. The first one is the damage cost, and the second one is the abatement cost. And we draw two lines representing the marginal abatement cost curve and the marginal damage cost curve. So the intersection of those two lines is the optimal level to abate, or the optimal level to abate, or the optimal level to pollute, because at this point the total cost would be minimized, and so we say this one is the optimal level. And we cannot apply the same technique to solve the climate change problem, because when we are talking about the marginal abatement cost, marginal damage cost, we are focusing on the marginal, right? For the climate change, it is not a marginal problem. It is not the flow of emissions per period, but the total accumulations of greenhouse gases that leads to the damages. So because of that, we cannot use the traditional environmental technique to solve the climate problem. And why it is a global public good problem? Because it is globally, it is a public good. We cannot exclude people from consuming, from being affected by the climate change. So it is very difficult to price the quality of the climate change or the consumption of climate change. And the impact of climate change is non-rival, which means my enjoyment of this climate would not impact your enjoyment. So it is very hard to generate the global agreement or cooperations, and that is the challenge of the climate change problem. And then discuss three potential impacts of climate change and what is the difference between adaptation and mitigation policies for climate change. Give one example of adaptation and mitigation policy. Three potential impacts of climate change we talked a lot, it affects the agricultural productivity. It rises the sea level. Also, it leads to the urban heat island. It is harmful for human health. All those are the potential impacts of climate change. And what is the difference between adaptation and mitigation policies for climate change? The mitigation policy is an attempt to prevent, slow, or alter the impacts of climate change, while the adaptation is the process of adapting behavior and decisions to prepare for or respond to climate change. So that is the difference between those two methods. Then give one example under each method, and it is very easy to find only one example from our lecture notes. So that's all about this topic. Then we will move to the city patterns and land use. Then we move to our third topic, the cities and land uses. We have talked about two models of the land use. The first one is called Ricardo model, and the second one is called Wang-Senen model. And the Ricardian model is talking about the land rent, which is the value of the difference in productivity between the same goods under same conditions. So that means when we plot the same crop on different lands under same conditions, the only difference would come from the productivity of land. So that is the only source of the difference of our final profit. And for Wang-Senen model, the only thing that matters is the land. Is the location or is the transportation cost. Everything else are being equal, and we only think about the transportation cost. So that is the Wang-Senen model, and for the Ricardian model, we only think about the productivity of the land. And for question D, when we are given three different bit-rent curves for tomatoes, peas, and wheat respectively, and given those informations, we are required to plot the Wang-Senen model of land use around a CBD. So as we can see from this graph, when the distance to CBD is less than 2 miles, we will only grow tomatoes. Why? Because farmers who grow tomatoes, they are willing to pay the highest rent for the land. And when the distance is greater than 2 miles but less than 6 miles, we will only grow peas, because within this range, the bit-rent curve for peas is the highest one. And when the distance is greater than 6 miles, we will only grow wheat, because farmers who grow wheat, they are willing to pay highest rent for this area. So according to this information, we can plot the Wang-Senen model. Suppose there is a dot and represent the CBD, and within 2 miles of this dot, and within this circle, we only plant tomatoes, we only grow tomatoes. And when the distance is greater than 2 miles but less than 6 miles, within this range, we only grow peas. And when the distance is greater than 6 miles, we only grow wheat. So that is the Wang-Senen model. Then explain why firms are more likely to be located closer to CBD compared to households. Or we can say why households are more likely to be located far from the CBD compared to firms. There are several reasons for that. First, information is very important for firms, and firms, they need easy access to information. They need to negotiate with other firms. They need to interact with other firms, and the costs are lower if they are located closer to CBD. They can also decrease the transportation cost of their workers when being closer to CBD, and in that way they can control their costs and improve the profit. All those reasons explain why firms are more likely to be located closer to CBD. And the next topic is the environment and development. And it would be our final topic from this practice exam. What is an environmental coolness curve and what shape or shapes should it take? And so the environmental coolness curve just represents the relationship between per capita GDP and the environmental degradation or environmental pollution. And in our lecture notes, we talk about the three different coolness curves like I show here. The first one is the inverted U shape, and this relationship is typical for some suspended pollutants like SO2 or NOx. And the second one is the continuously decreasing one, and this relationship is typical for some water pollution. And when we have more money, we would get the cleaner water. And the third one is about the continuously increased relationship between the pollution and per capita GDP. And this relationship is typical for some greenhouse gases like CO2. So that's all for coolness curve. And then name one hypothesis on the trade and the environment. Explain what the hypothesis suggests. When we talk about the relationship between trade and the environment, I said that some developing countries are pollution havens, and this is one of our hypotheses. And they are the pollution havens because they just have a low cost to produce pollution, and they fail to control the negative externalities from the pollution. And in order to capture the market share, they need to control the low cost of the pollution as much as they can. So that's about the pollution havens. We also talk about the race to bottom hypothesis, and which tells a similar story as the pollution havens. So that's all about the hypothesis on the trade and environment. And I think that's all for the practice exam. And let me know if you have any other questions. And good luck.